July 16, 1990, a magnitude 7.7 along the Philippine Fault Zone, epicenter in Nueva Ecija. Baguio was hit hard. Landslides severed the city from all roads. Buildings, hotels, and homes collapsed. An inland fault with devastating secondary hazards. October 15, 2013, magnitude 7.2 beneath Bohol. A shallow source produced violent shaking. Roads and bridges failed. Centuries-old churches crumbled in seconds. Late 2019, several M6+ quakes over weeks, causing cumulative damage and distress. Each event adds painful data that refines hazard maps and preparedness. None are isolated. All are echoes of a continuous geologic process. Understanding turns tragedy into lessons for a safer future. The same forces that cause earthquakes also build the archipelago's volcanoes. Water from descending slabs lowers melting points, generating magma that feeds volcanic arcs. Iconic peaks, Mayon, Taal, Pinatubo, are surface expressions of deep magmatic processes. Rising magma fractures rock, producing distinct volcanic tectonic earthquakes. Major tectonic quakes can rattle nearby magma systems, sometimes influencing eruptive behavior. In the Philippines, faults and volcanoes often sit side by side, fire and earth intertwined. Living here means accepting that the ground is never truly still. Situated where tectonic plates collide, the archipelago is in constant motion. Science provides crucial tools for understanding this. Seismologists map active faults and measure plate motion. While they cannot predict the exact moment, they can forecast long-term probabilities, identifying which faults are accumulating the most strain. This knowledge creates hazard maps that guide safer land use and informs modern building codes. When enforced, these codes and the retrofitting of older structures are proven to prevent collapse and save lives. But engineering is only part of the solution. The primary defense is a culture of preparedness. Regular drills, public education, and clear evacuation plans empower communities to respond effectively. A primary concern is the big one, a projected magnitude 7.2 earthquake from the West Valley Fault. A rupture could generate violent shaking across Metro Manila for up to a minute, with the most intense motion near the fault line. The fault could slip by several meters, triggering powerful aftershocks. Secondary hazards would be widespread. Liquefaction in reclaimed land and river deltas, landslides on steep slopes, and fires from broken gas and electrical lines. Because the West Valley Fault is inland, it won't generate a tsunami. However, the threat remains high from offshore ruptures in trenches like the Manila Trench, posing a grave danger to coastal communities.